Welcome to part 2 of concrete mix design tutorial. If you have not seen part 1, then the link for the same is in description box. So let's begin with part 2. Few of you have suggested me to solve the illustrative example given in IS 10262-2019. So I will start with the sample example. After that, I will show you the Excel sheet for quick calculations. This is the given data for the problem specified in IS 10262-2019 Appendix A. Also, keep a close view on cement type, designated grade, exposure condition and aggregate type given in this problem. Also, have a look on the test data we tabulated in this problem. First thing, it is said that we need to design the concrete for M40 grade. But the question arises, is M40 grade sufficient for extreme conditions? So, to check that, let's take a look on table 5 of IS 456-2000. According to this, for RCC construction and severe exposure, minimum specified grade is M30 and we are designing for M40, so it's completely fine. So let's design for M40. Step 1 was to calculate the target mean strength of concrete. There were two expressions specified by Indian standards. If we calculate the values for these two expressions, we get the maximum value to be 48.25 MPa, which is to be considered as target mean strength of concrete. Step 2 was selection of water cement ratio. From the chart given in IS 10262, corresponding to target strength of 48.25 and for the PPC cement, water cement ratio comes out to be 0.36. This has to be checked against the maximum permissible water cement ratio as per the exposure conditions. So if we look at the same table, that is table 5 from IS 456-2000, for severe exposure and RCC construction, the maximum permissible limit is 0.45. So the value chosen from the chart is lower than the maximum permissible value and hence 0.36 is adopted. Step 3 was estimation of air content. From table 3 of IS 10262-2019, if we look for 20 mm aggregate, we can get the percentage of entrapped air to be 1%. Step 4 is selection of water content in the mix. From table 4, for 20 mm aggregates, the basic water content value is 186 kg per meter cube of concrete. To this value, 3 corrections needs to be applied. Correction 1 is for aggregate shape correction. In the problem statement, we have angular aggregates, so there is no need to apply this correction or simply subtract 0 from the basic quantity. Now we have WC1 equals to 186 kg per cubic meter of concrete. Correction 2 is for slump value correction. As per the IS recommendations, we need to increase the water content by 3% for every 25 mm of slump increase. Default slump is 50 mm. So as per the given data, expected slump is 75 mm. So the excess slump will be 25 mm. Hence, increasing the water content by 3%, we can get the WC2 to be 191.58 kg per meter cube of concrete. Next correction is for admixture addition. From the test data, it is known that adding 1% of admixture, 23% of water reduction can be achieved. Hence, WC3 turns out to be 148 kg per meter cube of concrete. This will be the final water content in the mix. Step 5 is the calculation of cementitious content. We know the water content as well as the water cement ratio. Therefore, cementitious content is found out to be 412 kg per meter cube of concrete. But this has to be checked against the maximum and minimum permissible cement content criteria. If we check for those criteria, we can see that we are satisfying both the limits and hence cementitious content 412 kg per meter cube of concrete is to be finalized. Next step is obtaining the admixture quantity. As per the problem statement, we are adding 1% of admixture. Therefore, quantity of admixture turns out to be 4.12 kgs per meter cube of concrete. Step 7 is proportioning the coarse aggregate in the mix. We have nominal size of coarse aggregate to be 20 mm and zone 2 for fine aggregate. Therefore, basic proportion has to be selected from table 5, which comes out to be 0.62. Further, two corrections needs to be applied on this value. First correction is water cement ratio correction. As per the standards, we need to increase the coarse aggregate proportion by 0.01 for every decrease of water cement ratio by 0.05. Standard value of water cement ratio is 0.5, whereas for our mix it is finalized as 0.36. Therefore, if we calculate the factor of change for slab of 0.05, we get the increased proportion of coarse aggregate to be 0.648. Second correction is for congested reinforcement or pumpable concrete. But in this problem statement, we need non-pumpable concrete and even we don't have congestion. So we can skip this correction. Hence, the final proportion of coarse aggregate is 0.648. Step 8 is for obtaining the fine aggregate proportion. It will be simply 1 minus coarse aggregate proportion, and therefore the fine aggregate proportion is 0.352. Step 9 is obtaining the volume of ingredients. Depending on the mass of ingredients and their specific gravities, we can get the volume of each ingredient. Like volume of cement comes out to be 0.143 meter cube, volume of water to be 0.148 meter cube, volume of admixture to be 0.0036 meter cube, and volume of air content that we have directly taken from table 3 is 0.01 meter cube. Now we have to deduct all these volumes from 1 meter cube of concrete to get the volume of aggregates. This volume comes out to be 0.695 meter cube. We know the expressions to calculate the quantity of coarse aggregate and fine aggregate. The coarse aggregate is found to be 1234 kgs per meter cube of concrete and fine aggregate to be 648 kgs per meter cube of concrete. This table gives the quantities of aggregates in the mix, and the following table gives the proportion of ingredients with respect to cement content. Last step is applying the site corrections. From the test data, we know that we have only water absorption in coarse aggregate and fine aggregate. If we apply the correction as per the expressions given here, we get the value of fine aggregate and the coarse aggregate to be 642 and 1228 kgs per meter cube of concrete. Indirectly, 12 kgs of water is absorbed by aggregates. So we need to add 12 kgs of water, and hence the final water content becomes 160 kgs per meter cube of concrete. These two tables gives final quantities and proportion of ingredients in the mix. Now let's move to use of Excel sheet to reduce the calculation efforts. I received another suggestion to add the clauses of concrete bridge code so that one can design the mix for bridges. So in this file we have two sheets, one for normal works such as buildings and the other for bridges. The design procedure is same for both the works, only the permissible limits on bridge mix designs are on conservative side. So let's start with the explanation. Let me zoom the Excel sheet. All the entities marked in orange color are the input parameters. However, the quantities in dark yellow color are to be the input parameter only in certain situations. The first row says that the type of design you want to make, whether you have to go for ordinary design or the design for bridges. But I have created two different sheets, so we should not think much about the first row. Second row is about the type of concrete you want to design. So there are multiple options to go for either RCC or PCC. Then it will ask for the exposure conditions. Again, there is a drop down menu which has multiple options such as mild, moderate, severe, very severe and extreme. You have to choose type of exposure condition. Then it will ask for grade of concrete to be designed. Again, there is another drop down menu in which the grade of concrete varies from M10 to M55. So let's make a choice of M40. Then we can see multiple white spaces in between. There is no need to give any input to these blocks. This is because the values obtained in these blocks are totally dependent on the inputs we gave in above 3 rows. Depending on the exposure condition and the type of concrete you are choosing, the value of maximum cement content and minimum cement content will be automatically taken as it is coded in the background. Then the next input is the type of cement to be used in the mix. Now again, here we have multiple options such as OPC 33, 43, 53. Depending on the type of cement we are using in the mix, we have to choose this option. Then it will ask for, do you wish to enter water cement ratio manually? There are two options like yes or no. Also, there is one note given here. Please enter yes if you wish to enter manually, or else press no if you want to choose automatically. What does this mean? So let's choose yes from the option. What it will say, it will turn the value in the red. It will say please enter the value. This means that entering the value into this dark yellowed box is mandatory now. So you can enter the value manually like 0.3 and it will use the same value in the calculation. But if you will choose no, then what will happen? It will automatically calculate the value based on this curve depending on the target mean strength you have already obtained and the type of cement you are using in the mix. These curves are plotted using the curve fitting method, in which I have developed a cubical equation for each of the curve, and depending on the target mean strength it will automatically calculate the water cement ratio. Let's try this out. I will select no here, then it will automatically give 0.35. If you want to change this, then what we will do, I will do it here. Like suppose if I am doing for the moderate condition and I will go for the design of concrete, let it be M35 grade, then
it will automatically change to 0.38. And then in that case, even if you do anything here, it won't be affected anyhow.
Now the next input parameter is maximum nominal size of aggregate. So again you have a drop down menu to choose for 10, 20 or 40 mm of aggregate. Then it will ask for zone of aggregate. So there are 4 options for it, like zone 1, 2, 3, 4. You can adopt whatever zone you have. Depending on these two input, it will automatically calculate the maximum water content in the mix. That is what we call as a basic water content. So this is 186. If I'll choose like suppose 10 mm of aggregate, then it will automatically change to 208 kgs per cubic meter. Then we have to give the value for the expected workability, or what we call it as a design workability. For it we have the input parameter here. So you have to input it like 100 mm or like a 75 mm or like 150 mm, whatever is your value. Then it will ask for the method of transporting and placing. So there are two options, either pumpable or non-pumpable. This is because it will affect the proportion of coarse aggregate in the mix. For instance, let it be non-pumpable. Then it will ask you for the type of aggregate you have in your mix. So there are again multiple options like angular aggregate, subangular aggregate, rounded aggregate, or the gravel with crushed stones. These you have to choose depending on the type of aggregate you are using in the mix. Now 2 more rows are there which are for admixture. So admixtures can either be plasticizer or super plasticizer. You will be adding any one of these into the mix. So both of these cannot be yes. What if you will do both of these yes? Then it will give you the warning that both the plasticizer and super plasticizers cannot be added at same time. So either you make no for the plasticizer or no for the super plasticizer. Suppose I will do no for the plasticizer, that which means that I am adding superplasticizer. Then it will ask you for the percentage of admixture as a weight of cement.
So if you will enter like 10%, then it will say the percentage cannot be greater than 2, because this is the limitation
Given by the Indian standards that you should not increase the percentage of admixture beyond certain limit. So for it we can have the maximum 2%, so let it be 1.5% for now. Then at the last you need to give the input for congested reinforcement. Do you have the congested reinforcement or not? If yes, you can go for yes. If you have no, then you can select no. These all will be the input data. Then there comes a test data in which you have the specific gravity, water absorption and the expected water reduction in the mix. If you give all these input parameters as well as the test data, then at the end you will get the final values of lab mix design as well as the in situ mix design. Presently it is saying some no value or something like this because we have given some haphazard values here, so they are showing like no value. But if we'll give proper values here, then it will be actually showing the values. Okay, so now let's try out one example. Now let's see the example in Excel sheet. We will be considering the same example what we have discussed in the tutorial, the similar example given in IS 10262 2019. This is because we can compare the results of manual calculations with the Excel sheet calculations. Okay, so now the type of concrete is RCC, the exposure condition was severe, the grade of concrete to be designed was M40, type of cement to be used is OPC, PPC, correct. Do you wish to enter? If I'll say no here, then it will automatically take 0.35, but in the manual calculations we have chosen the value to be 0.36. For that purpose I will do yes here and will enter the value as 0.36. Maximum nominal size of aggregate 20 mm is fine. The zone of fine aggregate is zone 2. Expected workability is 75 mm. Concrete is non-pumpable. Type of aggregate is angular aggregate. Plasticizer will be no. Instead we will be using superplasticizer, so I will make it yes. The percentage is given as to be 1%, so it's fine, and the congested reinforcement is no. Now if we see the specific gravity, it's 2.88. This value is 2.74. This is 2.65. This is fine. The percentage reduction is 23% and the free moisture content is nil, so it's fine. And if we give the all the values properly, then at the end we are getting the values to be these. So let's compare those with the values we obtained manually. So we can see both the values are almost identical, only coarse aggregate is just 1233 instead of 1234. This is because of the rounding of error, because we can see here the volume of total aggregate is found to be 0.6944, whereas in the manual calculation it was 0.695. Because of this a small error is there, but it's acceptable, and if we apply the corrections to it, then at the end the proportions we are getting is again exactly identical except for the coarse aggregate. And even if we see the proportions of mixed design, those are also identical. So here we can see that we can successfully use the Excel sheet as an alternative to the manual calculations when we are preferring to use the procedure again and again. Now let's have a quick review for the design of concrete mixes for bridges. The design for the bridges is almost similar to that of the ordinary concrete, but there are very minor changes in the design sheet. The first change is the type of structure. We have to choose what type of structure we are expecting to be designed, like it will be a important bridge or a PSC bridge, or else we are designing a non-PSC bridge. Depending on the selection, the values for the maximum water cement ratio and the minimum grade of concrete required varies. Then the next correction is for type of concrete. What changes here is like we have the option of pre-stressed concrete also, because if we are selecting the PSC bridges, then the PSC criteria has to be included. Next one is the exposure conditions. There were 5 conditions in the previous sheet, but now there are only 3 exposure conditions. Mild and very severe is completely eliminated. The next change is the maximum cementitious content limit, which was 450 kgs per meter cube in earlier sheet. Now it's 500 kgs per meter cube. Apart from this, there are no major changes. The working of this sheet is exactly similar to what we have seen in the earlier process. If we'll give the whole test data and the lab data, then what we will have is at the end we can directly get the values for each and every ingredient along with the proportions with respect to cement content. Also, if we apply side corrections similar to the previous sheet, we will get the final updated quantities and the mixed design proportions. To practice this, I have uploaded a sample sheet for these 2 design mixes. However, if you wish to have the complete version of this Excel sheet, you can drop a mail at design.education2020@gmail.com. Thank you.